You like stand in front of the whole time and smile. This one should be good because we'll get two different perspectives.
Yeah.
See? We won't miss a thing.
Are you guys getting this on tape?
Oh yeah.
Okay.
Oh, yeah.
We're not I believe it, actually. Oh, sensitive topic. Sensitive topic.
She knows.
Like, it's one thing to talk like just I got his milk. I'm gonna get his milk. Okay, you have to go like promise. No. Promise.
Wait, why? Yeah, we are.
You know, Michelle.
Yeah. Oh my. Oh, David, your head.
Are you gonna play basketball?
Okay, welcome. This is the big week. We have, unfortunately, we have this exam on Wednesday and Thursday, and we also have a class exam on Tuesday. Just in case you're wondering, if we have, there'll be a class exam review tomorrow night at the same time. So if you're interested in that. But for now, let's focus in on lab. And if there are some of you recording this, I'd like to make a request. I wouldn't mind if you don't mind sharing that, your video of that, and maybe I can put it together. It probably won't, I'm sure that won't happen before the exam, but eventually put it together to use as a, from different angles and stuff as a review for this. And with that,
Your head would be famous.
in view, I wouldn't mind if somebody up close wouldn't mind videoing it up close, so you just see hands. Okay, you don't even have to watch while you're doing it, just set it on there, and then if one of you guys would be willing to do that, or girls up here as well. So, if not, it's all right, no problem.
Wait, walk around and follow you?
Mm,
Like, walk around and follow
no. If you want to, it's okay. But, no, just zoom in close. You want to do it? Did you raise your hand? No. Good.
He's not gonna use it.
Oh, I'll do it.
No, I thought I saw you raise your hand, but maybe you
I can do
didn't. Or you
it.
had a question?
No. Wait, me? Okay. I can do it.
Well, you can do it if you want to.
Okay.
And, all right, let's see what happens. So let's talk our way through this, and then we'll actually go through it here. So some considerations here. Let's see if we can get this to click. Okay, first thing, relax. It's not that bad. You may feel a little bit terrified right now. It's really not that bad. Okay, secondly, you have everything you need right here in this lab 10. Looks like it's not clicking. Looks just like that, except in yours it says lab 10. Whoops, sorry. Not lab. Does it say lab 10 in your book or lab 9?
No.
Lab 10.
That's 10.
Thank you. Thank you. It did do it though, but thank you. I appreciate that. Anybody bring your lab book with you? I want to make sure it's there. Yeah, okay. I went through and changed it in my book for printing out for next year. This is ended up being in the wrong place. But, so it is lab 10 in yours. Looking out? Thank you very much. And these slides I'll put up tonight after we're done here. So, and I'll correct that. So it is lab 10 in your lab manual. Everything's there. All the stuff you need to know, that you need to do, and all the equipment that you'll have, and even the page that you'll see when you come to lab. I'll show you that. If you need more details than are there, go back to lab 6, and you'll get those details there. So come at your time. I've already put them up on Canvas. There's no PLQs, by the way, this week. You can just go and look and see that, oh yeah, I signed up for 3 o'clock, and make sure to be there at 3 o'clock. So what do you bring? Pencil, whoops, pen, not pencil. Okay, pen and a calculator, and that's it. Bring those 2 things, pen and a calculator. What affects my grade? Well, read that lab manual very carefully, and it tells you exactly what affects your grade. So what are you going to do? Well, let's think back to what you did in lab 6. The first thing you did was standardize some KHP, kind of a little bit like what you did last week, only it was pure KHP, and you did it to find out what the concentration was of this. That's already done for you. You will be handed, or it'll be sitting there, a bottle of already standardized sodium hydroxide. So all you have to do is use it. This is the part you'll be doing. This is the lab exam, and it's exactly what you did in back in lab number 6. You'll take some acetic acid. It just won't be vinegar. It'll be some concentration, different ones that we have made, and your job to figure out what it is. So it isn't vinegar, but it's like vinegar. It's acetic acid solution. You will pipette 10 mils of that and dilute it to 100. And then you'll take 10 mils of that and pop it over here and titrate it. And you'll do that 3 times. And if you would like, you can do it a 4th time to increase your chances of getting it right. So that is basically what you need to do. So let's imagine we're coming into lab here. Now when you really come in to do the test, you will not be talking or asking questions or anything. And that's the way I'll do this procedure in just a little bit. But right now, I'm going to talk through things so that you point out some things to you. Then we'll actually go through the lab just as if I were you. And it'll be absolute silence at that point. So we'll be practicing even the silence. So your burette, you'll need to fill with a little bit of sodium hydroxide and rinse it out. Do that a couple times. Let it run down through the tip and make sure there's no bubble of air in the tip. You can fill that thing up and let it sit so it gets all the bubbles out of it while you take your unknown, which you all have one. Yours will be in a plastic bottle. It'll be the same size as this. You write down your unknown number on your sheet, and all of your glassware will be wet because the people before you have just used it. And so that means you need to make sure and not let the water mess up your experiment. So this beaker is wet here. I made sure they were wet before I came down here. And before you do anything though, what are you going to do? Safety goggles. So you don't want to have rinsed that. Already messed up. You don't want to rinse anything before you put this on. So you rinse. Then you come over here and you pour a little bit in here and rinse out the water a couple times. Just a little bit. Then, otherwise it'll dilute your sample and you get the wrong answer. Then you pour a little bit of this in here, rinse out your pipette a couple times like you've practiced. And then finally pipette 10 mils of that into here. This will be empty for you to save time. Usually you get a full volumetric flask and you have to empty it before you use it. It'll be like this, but it'll be clean. So you will just water. All you need to do is pipette in your 10 mils, dilute it up to the mark, and mix it really well. Okay. That means do that about 8 times. Really, really well. Then you pour some of this out into a beaker and rinse it out with the now dilute material 2 or 3 times. And then you're ready to pipette 10 mils into here. Whoops, no you're not. You'll pour it into there. Then you'll have to rinse out your pipette again with the new stuff. You always rinse out a pipette with the material you're going to be titrating. So you rinse this thing out again, then you pipette 10 mils, 10 mils, 10 mils. 2 drops, 2 drops, 2 drops, phenolphthalein. And then you're ready to titrate. You will have a paper towel, you'll have a plastic dropper here if you'd like to use that. You have a pipette bowl, you'll have your unknown, your sample. This is phenolphthalein. Here is your sample. Don't ever stick any pipettes in here. That messes up the concentration. You always just pour these out. And you'll have a wash bottle, which you can use to bring this up to the mark, or if you'd rather, you can use a dropper to bring it up to the mark. That's your choice, but you'll have both pieces of equipment. You won't need to get into your locker at all. It's kind of cool. You come in, you'll have your
whole setup right there. It's just your own wash bottle, water bottle, your own waste bottle. Everything is just right there. And you come in and do it, calculations, and you are done. So let's get ready to actually go through it now at this point, as if you're coming in. Say you had a 3 o'clock appointment, and you come in there a little bit to the hall a little bit ahead of time, and you're waiting until the TA calls you to come in, and they'll point to you a place, and you'll go over to it. After that, once you come in the door, don't say anything. If you just make a sound, a verbal sound, it will count against you. Okay, so you don't make comments. Oh, this is hard. Oh, wow, look at that. Don't say anything like that. Okay, and you don't say, oh, what do I do next? That's what you're being tested on. So don't ask questions. Now, that being said, you come in here and you turn on your burette and nothing happens. Does that mean you have to just sit there and flunk because the thing is clogged up? No. If something is not working, you call a TA and they'll replace your equipment. You can say, hey, this doesn't work. That won't count against you. However, if you have about this much of stuff in a burette, that's not really enough pressure often to push it through. So lots of times people think their burette is clogged when they just don't have enough liquid there. So make sure you have enough liquid before you've asked that question, hey, my burette is clogged. And we also will have checked these to make sure that they're not clogged. We won't get all our clogged ones and put out for you. All right. There won't be any clickers as part of your equipment. Okay, so it's 3 o'clock. You're scheduled at 3 o'clock. Let me get this down. One more slide here. You have this sheet in your lab notebook. What you see in lab will look exactly like that, except that won't be there. Now I'm going to, before we actually start, I'm going to, well, let's put this. Yes. Yes. And when I do the experiment, I will be writing. The only thing different that I'll do than what you do is that I'll be writing my data on the board in this box. That's what you need to do. Oh, you won't have a board. You'll have a piece of paper with a box. Okay, but so well, I will do it here, but you will do it on your paper. Then right below that is a place for calculations. I'll come over here and do the calculations. And you can use the back if you need. So now, let's go back. And we're at 3 o'clock. Let's say John is my TA. He calls me in. And you only have 40 minutes from 3 to 3:40 or 1 to 1:40 or whatever to finish doing your work and turning in your calculation. If you go over that 40 minutes, there will be a severe penalty. Severe. So it's better to just turn it in at 40 minutes. Then you have that last 5 minutes to clean up. And when that's over, whether you're done or not, they'll say, okay, it's time to go. And at that point, all the TAs jump into action and they clean up everything and get it ready for the next group that comes in at 4. So that's the way it works. So somebody watch the time when we start, so you can get a feeling that how long it takes to actually do this stuff. So we'll start.
So we did, what time did the paper get turned in? 34 minutes. So we still had 6 more minutes, okay, on that. So good, good. I was afraid I wasn't making it. I was getting to where I can't even read a Burette anymore. You see this here. And you see another big mistake I almost made. In the pipetting. I started to, let's see, I forgot now what it was, but I almost did something very bad.
Then you forgot to lower it to the mark.
Yes, yes, I was going to put in 12 mils or something. That's exactly right. I had filled this up to here, and then I took it over and went back and let it down to the mark. Okay. Then another mistake I almost made, and that was to use the weight volume. Almost use the weight volume percent here instead of the weight. I started out, and then I switched. Make sure you use the weight percent. A lot of people make that mistake on the test. And I hope I didn't influence you to do that. Use the weight. In fact, I could hear an audible sigh of relief when I changed that out there. So you helped me. You weren't supposed to do that. I'll confirm I was doing the right thing. Make sure you use the weight. Let's see if that's right. Because you need the weight up here and you need the weight down here. So yes, that's right. Yes.
For the weight volume, it's times the 100, right?
Yes. Did I not do that? That's just 100 that looks like.
Zero.
You're right. It's supposed to be 100. That's what I did do 100 there. So it just, I think, I actually almost forgot to put that 100 there, and I scribbled it in, and it didn't come out. But I think I remember that anyway. Yeah. Okay, good. Let's ask questions now. Focus on the question that's asked. Yes.
During the test, we'll be given the density of.
It's written on the sheet. Okay. And it's the same number, 1.0052. Some other hands somewhere else. Okay, now notice something here. This is very important. The first endpoint was really not too bad. The second and third were really not too good. It's better to keep rolling than to worry about too much like that. Let's think. If it took about 7 mils, 7 milliliters to titrate, and we overshot by 1 drop, how much is a drop? It's 0.05 mils. Rule of thumb. Okay? 0.05. What's 0.05 out of 7 times 100? In other words, if you overshot by 1 drop, 0.05 out of, 0.05 out of 7 times 100, that would give you a 0.7% error. That's not a big deal. Okay? So keep this in mind. It's better to keep rolling and get it a little bit sloppy than to not make it to the end. Okay? The answer you get at the end is a lot more weighty than your endpoints. Yeah, we'll be watching those endpoints. But if, for instance, it turns in 1 drop and it got too pink, just smile at it and go on. Okay? And that's as good as we ask. Okay? You can try for better. You can try for better. Okay. Other questions? Yes.
What's up the volume class with the? Could you just quote it in? Like, do you have to mix it up? I mean, what's the name?
No, you do not need to clean this. It comes clean. Everything comes clean.
But then it's
The only time you have to rinse it out is when water is going to make a difference. So when you're putting your sample into water, that would dilute it. So you have to get rid of that until the water's all gone. But when you put water in here, you're going to add more water anyway, so water's fine. Good question. Yes?
What if when you're doing, when you do the switch, you get a really, really light pink and then it disappears when you put it down?
Then you're not there yet.
Not there yet, so I'd like
It
another.
has to wait 30 seconds. It has to hang on for, or it has to persist for 30 seconds. Mhm.
Going along with that, you just put it aside, you didn't shake it anymore or wait for 30 seconds. You put it aside, you kept going, and then you checked out.
Oh, okay. On those second two, when it's dark like that,
Yeah.
there's no 30 seconds. This is going to be like
But
that.
the
The first one,
just put it aside.
yeah, I should have checked that. Yeah, that could possibly have been a
So
problem.
should you just leave it or just wait for 30 seconds?
Did it go back?
It was pink the whole
Okay,
time.
so it was all right. I would say chances are, given the conditions of the experiment, you're not going to be in that case of it disappearing on you. You're going to tend to overshoot. So unless it's really, really, really light, you probably don't need to worry about that. And that one that was good really wasn't super light like I've seen some of you get. But yeah, I should have waited a little bit.
How do you get it less? Because you were just going one drop at a time.
One drop is all we expect. But at the very end, I gave half a drop. Okay, you're free to go anytime, but I'm going to go through the calculations one more time just in case you want to another hit on that. If you don't, no problem. We'll see you in class or whenever. Yes? I'm sorry.
Do we get marked off on the color? Like if it's too dark.
Yes. Yes.
Would you get marked up?
But that last two, probably. Yeah. But it's better to get that cut than to not finish. Just keep going. Now, if that happened in one drop, then you wouldn't get marked off if they saw it. Okay?
If they
So
saw
don't.
it, it's like you're lucky.
But here. It sucks.
Yeah, I saw that.
Yeah.
Okay, there. See the difference? That's the points weighting on the endpoints. Okay? That other big box is the points, the weighting of the points on getting done, getting all your calculations. Now, there's also accuracy. There's also some points in here about accuracy. And I don't know exactly what the percentage is, but accuracy and precision. Okay, the accuracy and precision is where the endpoint is kind of related to that. Okay, we count more on the numbers that come out than on the color of the endpoint. Although we'll be watching, and that could count against you. And those last two probably would count against you. Okay, and that's for sure the last one. When you look down here at precision, this is not good here. You want to try to do better than I did. Yeah. Because we diluted by 10. And we want the original concentration. Good question. Yeah.
So do we need to write down standard deviation of?
No. No. That's not part of it. Yeah. 18 and 19. Well, I thought. Okay, yes. You should use the significant figures that comes out of your data. So, in my particular case, now that's a good question. Did you notice it only took about 7 mils? So I used the beginning of the second one as the end of the first one. That saves you time. If your titration takes you, more than half of your ed, which it might, then you'd have to fill it up every time. Okay, but in my case, I could maybe have gotten 3 out of that one, but I just wasn't sure on the last one. So it was better just to fill it back up. Now, I had less than 10, which means I only had 3 significant figures here. This had 4, so you should use the significant figures that follow from your data. If I titrated and it took 10 mils to titrate, I would end up with 4 here, and so I should have 4 there. So it depends on your situation, probably either 3 or 4. Down here, there's still 3 down there. Good question, yes?
When you piped that, or you ready, and the second trial, you just went from where you left off,
Yes.
would we lose points if we filled it back up?
No, just time. Sort of, but some people will have to fill up. They're different concentrations, and so it won't hurt if you do that. Okay, so the next thing I have scheduled here okay, so don't get hung up on trying to be perfect. It's better to have a little less than perfect technique than to not finish the experiment. And you saw me, I didn't plan to mess up, but I did. I just keep going. Keep going. Okay, now, there's some mess ups that would have really messed it up, though. That one where I put the 12, almost put in an undrained burette, that would have really crunched me. Okay. Another thing I did that I wouldn't recommend is I got too carried away about rinsing that first beaker. Did you see that? I rinsed that 3 times. And then when I got down to the end, I was a little bit worried if I was going to have enough unknown. Okay, that was overkill. 2 times. Okay, follow the procedures, do your best, keep moving on. So, if you want, I'll run through the set of calculations more time. If you don't need to worry about that. So,
with the cleanup time, Dr. Clark, did you use the 5 minutes part of the 40 minutes, or is that beyond the 40 minutes that you use the 5 minutes?
40 minutes is just for doing the experiment and doing the calculations. That last 5 minutes is only for cleaning. You can clean long before that if you get done. But you can't do anything but clean during those last 5 minutes.
Okay, so you turn the paper in at 40.
Yes.
Okay.
Yeah.
Because
You don't have to turn it in. You have to waste your time. Where's the TA? And run over and find him. We'll take care of that. You're just leave it alone after 40 minutes.
Okay. And you start cleaning at that.
Yeah.
Okay. Sweet.
Yeah. Good questions. Yes.
On that last calculation there, we went morality, the 1 minus the % weight, what is the 1 for?
Because if there is 0.5% weight, that means there's 0.05043 grams of acetic acid per gram of solution.
Oh, okay.
And that's 1 there, implied. So that means the rest of it, 1 minus that, is water. And that's where that comes from.
Oh.
Yeah. Okay. Because
Yeah, that's the hardest one. It's the hardest one. And I was having to think about that. So even now. But that's right.
Okay. Yes.
If you find the average molarity, can you just use that value and put that in? That's what you did.
That's what I did.
That's
You calculate one molarity, and then all of these you only do once from that.
once you calculate the average.
Yes, yes. Yeah, exactly. You don't need to do that 3 times. That would be horrible. Already horrible enough. That would be more horrible. Okay. So let me write this data down. And we'll do this example if you would like. Today's today.
The fourth.
Fourth, thank you.
Times 10.8443. What's that?
Basically, we have the average.
No. What's after that? HAC.
Oh, that's
There's
nice.
3 letters.
I think.
Dr. Clark. When you multiply the standard deviation by 10, and
The
you have,
molarity by
yeah,
Yeah.
and then you have HAC, and then there's 3 letters and an arrow, I think. I'm not sure what that is.
Just a second here. Okay, so which one?
Up above on the top board, times 10 equals, then we have HAC, and then there's 3 letters inside the box. And what are those 3 letters?
That's abbreviation for original. There
Is
you
that ORG then?
O-R-I-G.
Oh,
You don't have to say that. I just was pointing out that's the original form.
okay.
So let's try another one if you'd like. So here we go. Take 16.52 mils of 0.098982 molar sodium hydroxide and titrate 10 mils of 10 diluted acetic acid. Calculate these 4 things just like molarity, percent weight volume, weight, and molality. So we have 0.016652 liters of 0.098982 moles of sodium hydroxide per liter, and there's a mole of acetic acid for every mole of sodium hydroxide. And that number of moles of acetic acid was in 0.01 liters. So that'll be the first molarity of the diluted. And this only has data for 1 run, so we won't have to, but you would do it for 3 times. You notice I didn't show the repeat calculations. There's no need to do that. Just show it once. 0.01652 times 0.098982 divided by 0.01, 0.1635. And we've got 4 significant figures this So it's a good idea to carry along one more. And so times 10, stuff is 1.635 molar, even the original solution. So the percent weight volume is going to be 1.6351 moles per liter converted to grams per mil. So there's 60.05 grams acetic acid per mole, and there is a liter, there's 1,000 mils per liter. So we end up with grams per mil, then we need to multiply by 100. And there you see another one of those hundreds that looks like that. .819. This is the case of 4 significant figures. We're going to change that to percent weight. 0.098192 grams per ml. There's 1.0052 grams per ml of solution. This is mil solution, grams of solution per mil of solution. This is grams of acetic acid up here. So times 100. You get 9.768. And your percent weight and weight volume shouldn't be very different. And then molality is 0.09764 grams over 1 minus the rest of it. In other words, 9768 grams, kilogram for every 1,000 grams, and mole for every 60.05 grams, times 100. Oh, carry away on times 100. No times 100 on molality. Grams per kilogram, that's little m. So 1 minus 684 divided by 1,000 times 1.802. That's it. So we'll see you later.
Thank you very much, Dr. Clark.
You're welcome. Thank you.
Too bad.
See you at the next chemistry.
Thank you.
Yeah, you will.
Thank you very much.
You're welcome.